So next part is the thermal physics, and we are going to take the first part, that equations of the gas. And first question is question number 2.7. It states a vessel of volume V is evacuated by means of piston air pump, right? One piston strokes capture the volume delta V. How many strokes are needed to reduce the pressure of vessel by eta times? The process is assumed to be isothermal and gas is ideal, right? So in this case, basically there is a container, okay, and we just trying to remove the gas from it. Okay. When we put a stroke here, then each stroke volume is getting changed, right, by V plus delta V. If it is initial V, then it is changes to V plus delta V. Okay. Now we have to find out number of strokes when this pressure is reduced by eta times. Okay. This is our objective. Okay. So let's analyze one by one. Let's assume the initial density is rho. Okay. So when we put the first stroke here, then there will be change in volume and definitely there will be change in density also. Okay. So we can write rho into V. Initial volume, let initial volume is V, is equals to rho 1 V plus delta V. Right. So from here we can write that rho 1 is equals to rho V over V plus delta V. Okay. Now if we consider the second stroke, because we can solve this problem using mathematical induction, that you just need to look at the pattern in one step, two step, okay, and then you can form a proper function according to that variation is taking place. So if you talk about second stroke, let's see after second stroke. Okay, so again there would be change in density and there would be change in volume. So density rho 2 is equals to V plus delta V, okay, is equals to rho 1 into V. Okay, so if we'll calculate rho 2, then what we'll get? Rho 2 is equals to rho 1 V over V plus delta V, right? And we can substitute rho 1 from the equation number 1. So from equation 1, we'll get rho 2 is equals to rho V square over V plus delta V whole square. Okay, so now we are getting a pattern that how density of this gas is changing after each stroke. Okay, in first stroke power was 1, in second stroke power is 2. So we can apply concept of mathematical induction that at nth stroke, the density would be V over V plus delta V to power n, right? So this is a relation that how density is changing after each stroke. Now we know that the pressure applied by a gas is proportional to the density of it. Okay, so pressure is proportional to the density, right? So if we have got the pattern of density, then we can write how pressure is changing. So as per this relationship and this finding, we can write pressure after nth stroke, where let me write it as n because there is one more parameter. So this is P naught into V plus delta V to power n. Right. Now we can take the ratio this Pn over P naught. So Pn over P naught is equals to V plus delta V to power n. Right. Now we know this Pn over P naught is given as 1 over eta. It is equals to V over V plus delta V to power n. Now we have to calculate this n, so we can take logarithm on both the sides. So this is minus log eta is equals to n times ln V over V plus delta V, or we must write ln both the side or log both sides. So there must be uniformity. Okay. So from here we'll get eta is equals to ln, or n is equals to ln eta over ln, because there was negative sign, so we can change it, upon V. Okay. So this is our final answer, that after this many strokes the pressure will change